It comes at you as a breeze, as a gust, as a gale, or in the scariest of situations, a hurricane or tornado at speeds up to 400 kilometers an hour. Moving air can be as delightful as it can be frightening. But how does wind happen? Here's a one-sentence answer. Wind is caused by air flowing from an area of high pressure to an area of low pressure. The long answer is that there are a bunch of variables that affect wind formation, speed, and direction, including the sun and the Earth's rotation. But let's back it up a bit. The air that's all around you, it's made up of nitrogen molecules, about 78%, oxygen molecules, about 21%, and water vapor, between 1 and 4%. When we talk about air pressure, we're talking about the amount of force that these molecules exert on a given area. When a mass of air warms, it rises and therefore exerts less pressure on the surface. And especially if that air is moist, that rising air can become unstable and create cloudy, rainy, even stormy conditions. That's why low pressure systems are often associated with bad weather. But that low you see on the weather map is only low in relation to the air around it. There's always a mass of cooler, drier air, usually coming in from a polar region, waiting to rush in, push that low out of the way, and sit right on top of the land. That's a high-pressure system, and when it dominates, clear skies usually come with it. So think of the wind as the atmosphere's eternally futile struggle to find a balance between these two competing systems. Air flows from high-pressure to low-pressure systems to try to reach equilibrium, and in doing so, creates wind. The closer the high and low-pressure areas are to each other, the stronger the wind. Now, unsurprisingly, the sun plays a big part in all of this, as it heats the surface of the Earth. About 2% of all the sun's energy that reaches our planet is eventually converted into wind energy, a small portion which we humans tried to harness. The spin of our planet also plays an important role. If the Earth didn't rotate, global winds would pretty much blow in straight lines with cold air flowing from the poles, heating up at the equator and then going back again. But the Earth's rotation produces a force on everything that's moving relative to the Earth, including air masses, a phenomenon known as the Coriolis effect. That rotation deflects the direction of the winds, to the right in the northern hemisphere and to the left in the southern hemisphere. Put it together, and these forces can do amazing things. According to most sources, the highest surface wind speed ever recorded was at the top of Mount Washington in New Hampshire. Wind gusts during a particularly brutal storm in 1934 topped out at 372 kilometers per hour. But in 1996, instruments about 10 meters above the surface recorded winds of 408 kilometers per hour during Cyclone Olivia off the coast of Australia. If it's all the same to you, I'll just take my gentle fall breeze. Thank you very much. And thank you to all of our viewers, especially our subbable subscribers, for continuing to support SciShow, shot here in the Keith Chim studio. If you have a question or a comment or just a good idea, you can contact us on Facebook or Twitter or down in the comments below. And don't forget to go to youtube.com/SciShow and subscribe.